In this video, I'm going to demonstrate to you how you can use DesignXL to do an underground mine design of stopes. As usual, I'm going to open up Excel, choose a blank workbook. Again, DesignXL is hosted inside Spatial Excel, so I'm loading it. And there is DesignXL. So I've set up a previously set up layer file which has all the data for our underground mine design. Now, as you can see here, our layers are loaded, and I'll zoom to fit the data. What we have here is basically a block model colored by grade of the gold value, and it gives us an idea of where the main ore body is. If I turn off values, we can get an idea of what we should be mining. So you can see those the perimeter I've drawn of this particular section here looks like a very good area that we should be mining. We can get a side view to get an idea of how it looks. So there you can go. So it is a tabular body, and I've drawn a perimeter around the area that I want to mine out. And since this is a 3D demo of a 3D stope face, you can see that this is definitely not that flat at all. It's got curves and everything in. The purpose is to show that we can handle this 3D case with ease with this tool. I'm going to view from the top again and zoom fit. So as I mentioned before, we're concentrating here on designing the stoping side, not the development side, in this demo, because the stoping is the most complex and has the most amount of volume, or takes the most amount of time in current tools. What I've done here is, besides drawing the perimeter of the area that I want to actually mine out, I've also drawn my raised line, which is this line going along here, and I put it in a separate layer so I can isolate it very easily. And this line itself is also not straight or level, just to show how we can handle this 3D case as well. To do the stope design, I've got various separate tools to design various parts of doing the stope of the mine design in terms of stoping. But I'm using now our advanced tool, which allows you to create your stopes very easily in one shot. First thing I need to do with this tool is I need to say what is the perimeter of the area that I want to mine out. I've already set that up. I chose it here by saying use selected. I'm going to choose the axis, what we call here the axis tunnel, but it's the raised line again, because I see a different one is being chosen. So I'm going to choose it again by selecting it in this way here. So I've selected that line string, which is going to be my raised line, and I say use selected, and now it knows that is there. Already, by just choosing that raised line, this tool has already put in some development panels for developing the raised line, and I'll show them to you by just hiding the block model, the geology, and there you can see those particular panels. What it's done for those particular panels is it's named them as well according to our naming format, which we've put in here. I've said here that the naming format for these development panels is going to be main dev and then times the workplace number from the beginning. So it's generated those names. How I can quickly check them out is by going to the stopes layer where these items are generated and turning on the text labels for the name. And there you can see all the names for these various panels automatically generated. So I started here, so that's main dev 1, 2, 3, and so on. So already, just by specifying the raised line, I've automatically broken the raised line up into these various panels. I've assumed here a width of 12 meters, which might be excessive, so I can reduce it. And I reduce it just by reducing it in the dialog. And as you see, as I do it, automatically the design updates. So it's very, very automatic in its process. I'm going to turn off the labeling of these elements just to make the screen a bit clearer. Now I need to specify the workplaces that are going to that I want to create on the left and on the right of this raised line. How the system works is I go into the Workplaces tab, and I can just enter workplaces as I go along. So I'm going to enter the first workplace. I'm going to say its width is 10 meters, and the length of the panels within that workplace will also be 10 meters for argument's sake. I'm going to say that workplace is starting right where I am, and already, as you can see, it's filled in all those workplaces for me as simple squares. Okay. The height and depth which I can enter here can be used to make the height and depth from these center lines of these workplaces be different values per workplace. At the moment I'm leaving it out because I'm going to assume a fixed height and depth for this whole stuff. So I'm just finishing entering that. Now what I can do here is I can specify what form of workplace this is. Just because I've created this workplace from scratch, it's got the default form, which is just a rectangle with no pillars or anything. Later on I'm going to change that, but just for now let's generate a few more to show you how the system works. My other workplaces are going to have the same kind of parameters, so I don't need to enter them each time. I can just insert multiple copies. So let me insert 20 along the left, and I just do that, and there you can see it's automatically filled these workplaces in, these panels in for me. You'll notice that the system automatically worked out how far up strike I needed to go to cover the ore body. It got that information from the perimeter that I entered. Also, it is really done it in full 3D. As I rotate this model around, you will see, I'll just fit it again to make sure we include everything. You can see how it's actually followed the 3D form surface and created the workplaces along the surface. I created now quite a few workplaces automatically without much effort. The naming convention it took from the naming convention that I entered in on the first page, tab here of the build stope dialog. And I said that the name of each one of these panels is going to be main dash followed by the panel name. And the panel name it gets from which side it is. So on the left side I've said the panel name is going to be W for West dash and then the workplace number and the panel number. To verify what we've done there, I can turn on my labels again for that layer to see what the names look like. So I'll go into name, and obviously now it doesn't allow the names to collide with each other. So if I zoom in a bit further, we'll get an idea, and there we go. You can see all my workplace names. So this one is a development panel. There's my first panel, second, third, fourth, and so on. This is all automatically generated by the system. I can view the actual table of what's being created by going into the view data here. And here you'll see that it knows about each workplace by name. It's got its geometry for it. It tells me what type, whether it's development or stoping. And there you can see stoping and development. It's also got placeholders for evaluation, which I will do later to get the value of the mineral content or the grade of the mineral content in each workplace or each panel. Okay, so what I'll do now is, since this format which I used for my left left panels, I want to use the same for the right panels. So it's quite easy to do. I'll first just view from the top so we get a nice clear view of what we're doing. So I want to now fill in some panels on the right hand side. Okay, so now I want to add workplaces for the right hand side. So I can just start and type to create them. Same kind of workplace. Again, I would like to put in multiple copies here, so let me put in 20, and automatically you can see there I've generated workplaces on the right hand side. Okay, that's all very well for very simple square workplaces, but what about pillars? Okay, so the system actually allows you to create any shape or style of workplace that you like. What I'm going to do is I'm going to clear the work we've done so far, so that I can actually start and create full panels. So I've cleared these panels. So now what I'm going to do is I'm going to add panels which have their own format. So what I'm going to do is I'm creating my first set there. What I'm going to do now is specify the particular template I want for that panel. So I open up a template list here, and I can choose a particular template. I see here there's a template here which I've created before called Simple Pillars. I'm going to use that. Now each template has its own set of parameters. So a simple pillar template assumes a pillar in the bottom left corner basically of the workplace, and it lets you give in the pillar width and pillar depth. Any kind of templates can be created which can have multiple pillars, various position pillars within the workplace. Also, if you only have pillars every 3 workplaces ahead, you can actually specify that some don't have pillars and so on. In this case here, I'm having pillars which I'm going to make 1 meter by 1 meter in these workplaces. In fact, I want to make it 2 meters by 2 meters for argument's sake. So that's the template I'm using. Now, as I created the template, or chose the template, you can see automatically my workplaces have updated to have a little pillar in the left there, as you can see. That happened automatically. Again, now I proceed as usual. I'm going to insert a multiple copy, and we're going to put 20 in over here. And there are my 20 workplaces created with all the associated panels. I'm going to do the same on the right hand side. What I'm going to do here as well, I'm going to choose actually the same template. And I'll choose the same parameters for that template, or I might even make them slightly bigger pillars for argument's sake. Maybe the width is a bit more. And automatically there you can see there's my templates with their slightly bigger pillars for the right. Again, I can insert multiple copies. And there we go. We have our panels automatically created, automatically going to the end of the ore body. No calculations needed there. And let me just zoom in, do a zoom fit to, and automatically following the ore body. So it really is in full 3D. I obviously want to mine out the whole ore body, so I can just add more templates and add more panels. I'm going to insert another multiple copy just to make it easy. 20 for the left, that should be enough. It's enough. Probably insert a few more. And I think that's far enough as far as mining goes on that side. Now I'm going to work on the right hand side. I'm going to insert multiple copy. Let's just say, I'll guess about 9 should do. There you go. And actually I want to go further, so I'm going to do a few more. Let's make it a bit quicker. Do 5. Okay, so now I've nicely covered my whole body. There is one tiny anomaly you might notice, is that my raise line needs to extend a bit further to start working up on the left hand side. As an example, I could extend that raise, and I can show you a very quick way we can use to do that. And let's just do that now. For example, we might not do it in this particular case in real life, but just to show you an example of how this is really a template driven model, I'm going to extend that center line. To do that, what I will do is, let me just view from top. I'm going to turn off what I don't need to see, and there just want to see my raised center line. So what I'm going to do is I'm going to zoom to fit where the center line is. So I'm in the center line plane. I'm going to choose to extend the center line, and I'm going to insert a vertex after to extend it, and I'm going to move it up to about there. So I've extended the center line. Now all I've got to do is to tell the design to use the extended center line. Okay, so it will go right to the end, and so that the actual development panels, as you can see, will go the whole way. To do that, all I need to do is to select this new extended center line. So I've selected it there, and then I go into access tunnel on this side here, and I say use selected, and automatically you can see it's extended it right to the end. What I'll do now, I'll just view from the top and zoom fit, and there we go. I can now add extra panels as needed. What I'm going to do first is just rotate and have a look. As you can see, I see an error, obviously on purpose. I have put that new center line has moved down too much. No problem, I can just edit it until it's correct. What I could do now again is turn off stopes and do my editing. Just verify that it looks all right. Okay, so I've adjusted my center line correctly. So now I just need to turn on my stopes again, which are incorrect, and use my new correctly adjusted center line. And there you go, you can see it looks much better. To view again from the zoom fit, and what we can do is let's just verify. I'll just fit to make sure we don't clip anything, and there you can see our panels are nicely covering our thing. I obviously made it too long. I can trim it, etc. in the same way. Okay, now that I've created all these panels with their pillars and everything, let's just do a look and see what the names of the panels look like. Just turn on our text labels to panel name. We can zoom in here and have a look. There we can see all the panel names for all the panels, and everything looks fine. Okay, now having created this part of the design, we can now evaluate our panels. Before I do that, we're just going to have a look and look at the panel data. Here we go. So here we have a list of all the panels created with their areas. Their volumes are actually 0 because they're only polygons at the moment. But for when we do evaluation, we're going to tell it to automatically extrude up and down to give proper volumes. But as we go through there, we can see there's our panels with their names and so on in the list. So to do the evaluation, what we're going to do So again, I'll right click on the layer I want to evaluate, go into Mine Design, Evaluation. It remembered the layer I used last time, my block model to evaluate with. It remembered my last two elements to evaluate. I'm going to evaluate silver as well. Okay, so we're going to use a fixed density in our evaluation. We're going to assume height is a fixed height, 12 meters above the center line of the stopes, and a fixed depth, 12 meters below the center line of the stopes, so that we can cover most of the areas there. Width isn't applicable because we aren't evaluating line strings at all, they're all polygons. So I can choose here on the right my minerals I'm going to evaluate. I'm choosing copper, silver and gold. I can also choose to increase the accuracy of the evaluation, to split the blocks up during evaluation, and I will do that right now to make it very accurate, or much more accurate. And then I just click evaluate, and the system's going to go through and evaluate the various. There you go. So we evaluated 1,311 panels. I'm going to close that now, and let's view the results of the evaluation. So here we go. We can see that these development panels all had values. Some of them didn't. They just went above, below, or went through gaps in the ore body. And we can go right through there. We can see all the values for every panel. So in this way, we were able to actually evaluate and create all these panels. This particular grid, I can actually select all the data and copy it and put it in Excel. For further scheduling or analysis, I have every panel with its name, with its values and its areas and what type it is, whether it's development or whether it's stoping. Also, when I was creating the access tunnel, I mentioned there's a parameter here called distance ahead. That is the distance ahead of the development that the development must go before you can start doing stoping on the left and on the right. And at the moment I've chosen a 0 distance ahead. I could choose any distance I like, but let's assume a 0 distance ahead. In other words, as soon as you've got to that particular position, you can start your stoping left and right. Once I've done that, I can actually now, I want to create dependencies between these particular items. So I'm going to create a dependencies source, and I say refresh dependencies. And what that does for me is it's going to create here a data source with all my dependencies in them. So I'm going to go in and view them. And here it's created it. So it's given me every panel and the panels it depends upon. So obviously here you can see that this particular stoping panel here depends upon a development panel, and this one depends upon the next one, and so on all the way down. If the distance ahead for development was greater, this stoping panel here would depend upon a later development panel. But here automatically, if we go down to the earlier stopes, you can see that this particular panel here depends upon the previous panel, and so on. So we've automatically actually created dependencies which we can now use in our scheduling of these panels. I can select all of these as well, and I can copy them. And again paste them into Excel for further use. That ends our stope design in 3D using DesignXL.